Hi students, today we'll discuss few interesting problems for JEE Mains and NEET. The first problem is that this is a vertical ring, it's a smooth ring, and there is a string that is fixed at the point A. And here you have a bead of mass small m. Bead is like a bob, like a pendulum bob, but the bead is inside the smooth ring. The ring is passing through the bead. So there will be some holes and it is passing through it. This bead is at rest on this smooth vertical ring. What is the tension produced in the string? To solve this problem, what we'll do is that we'll draw the free body diagram. So first thing first is you cut the string. Remember, this is the first rule of free body diagram. You cut the string, you draw the tension, you join this radius. Let us call O as a center. So you can easily see that OA and the mass small m, it forms what kind of a triangle? Isosceles. So this angle is theta. So obviously this angle, if I continue this line, is also going to be 2 theta. Now, if I extend this radius, mg is vertically downward. So the red vector is mg. It is vertically downward. If this angle is theta, this angle is also going to be, if this angle is 2 theta, then that angle is also going to be 2 theta. So I'll resolve mg into perpendicular component. One is along the radius and another is along the tangent. So along the radius, the component is mg cos 2 theta, and along the tangent, the component is mg sine 2 theta. Okay. Now tension. The component along the radius is t cos theta, and the component along the tangent is t sine theta. Once these components are resolved, you can easily see if this bead has to be at rest, then t sine theta and mg sine 2 theta, these are the two forces along the tangent, they must balance each other. So if I balance them, I'm going to get t sine theta is equal to mg sine 2 theta. So the answer of tension is mg sine 2 theta is 2 sine theta cos theta divided by sine theta. So you cancel the sine theta, and the answer of tension is 2 mg cos theta. I hope the solution is understood and clear. So second question that we're going to discuss is from friction. So let us take this as a horizontal rough surface. And here is a block. This block has, say, kinetic energy Ki, initial kinetic energy Ki. Now, when the block comes to point B, it loses velocity because the surface is rough. So it will have a kinetic energy Kf. Obviously, the value of Ki will be greater than Kf. The reason that the kinetic energy is getting lost because of the dissipative force called friction. Now, how much kinetic energy is lost? According to the problem, the kinetic energy lost, which is initial minus final, is the loss. The loss of kinetic energy is 3/4 of initial. And this loss of kinetic energy, that is a 75% of the initial, 3/4 of initial, is taking place in a time capital T. So 3/4 of kinetic energy is lost in time capital T. The question asks you, what is the coefficient of friction? So how to solve this? Let us take the initial velocity as V naught. As this block is moving on a rough surface, the friction acting on it is going to be kinetic, and the kinetic friction is in the opposite direction, and that is mu mg. So from the FPD along x-axis, you can easily see that this force mu mg is unbalanced. This means this block has an acceleration in the opposite direction of velocity, which is mu g, which is mu mg divided by mass. The acceleration that acts opposite to the velocity is known as retardation. And what we can see here is that this acceleration is constant. That means it will follow the equation of kinematics. So initial velocity is how much? U is equal to V naught. So final velocity, I have no idea. Let us call it as V. So the equation will be V is equal to U, which is V naught, plus A is going to be minus mu G. And in what time the velocity has turned out V? It is in time T. So the equation is V is equal to V naught minus mu G T. So I need the value of V. To get the value of V, I'll use this equation of loss. So what is the initial kinetic energy? It is half mv naught square. The final is half mv square. It is equal to 3/4 of half mv naught square. So what I'm getting is half mv square is equal to half mv naught square into 1 minus 3/4. So if I cancel half m, I'm getting v square is equal to v naught square by 4. This implies v is equal to v naught by 2. So I'll put this value here, and I'm getting v naught by 2 is equal to v naught minus mu gt. So mu gt is equal to v naught by 2. And this means mu, the coefficient of kinetic friction, is v naught divided by 2gt. This is the final answer. So V naught divided by 2gt. I hope this question is clear. We'll go to the third question. The third question is from circular motion. Let us take this as a hemisphere and a rough hemisphere. And let us say that an insect is crawling on this hemisphere. The coefficient of friction is given as mu. So the question asks that if the radius is r and the coefficient of friction is mu, what is the maximum height that this insect can crawl up to? So the point where the insect has gone maximum height from the ground, the insect is going to experience limiting static friction. The reason being, at that particular point, the insect will have the highest tendency to fall. And if that fall has to be balanced at that particular point, at point A, the part this insect will experience limiting static friction, and limiting static friction means that at point A, that particular angle is the angle of repose, and mu is equal to tan theta, right? Because mg sin theta is going to be balanced by mu mg cos theta. So if this angle is theta, and if I draw this as radius and this as the vertical line, you can easily see that if this line is drawn and this is the vertical, if this is theta, then this angle is 90 minus theta. And if this is 90 minus theta, the double one, that single red, this angle is theta. This implies this angle is theta. So if this is your R and this also is your R, which means that this height, this is the height that we need. And this height is how much? This height is R minus R cos theta, because this green height is the R cos theta. So the height H is equal to R minus R cos theta. But tan theta is equal to mu, and tan is perpendicular by base. So base is 1 and perpendicular is mu. So what is going to be your cos theta? The cos theta is going to be base, which is 1, divided by Pythagoras theorem. So the answer is R common 1 minus 1 by root under 1 plus mu square. So this is the maximum height up to which the insect has crawled up to. So I hope you enjoyed the solutions of these 3 questions. I'll keep on posting more questions in my next video. Thank you for watching. Please do subscribe. It helps me bringing a lot of interesting questions from JEE Mains, NEET, and JEE Advanced to you and discuss their solution and the theory behind it exhaustively. Thanking you again for watching. Bye. See you and take care.